Question number 35. What remains in the reaction vessel after equal masses, not equal moles, equal masses of potassium and chlorine gas have reacted until either one or both of the reactants have been completely consumed? Well, let's think about it. Well, is there any limiting reagent or like excess? Well, let's figure that out. So we're assuming equal masses. They don't really tell me how many grams of each, so I'm just going to go ahead and just come up with my random moles of gases, I guess, right? Or masses. So let's just go ahead and use some nice numbers. So what I mean by that is let's just go ahead and figure out the molar mass first. Well, potassium, as you guys should have on the periodic table, potassium has 39.1 grams per mole. I'm just going to say 39 for the sake of easy math. 39 grams per mole. And chlorine gas was 35.45, but I'm just going to say 35.5 rounded up. So 35.5, but you have two of that, so that's going to be 71 grams per mole. So what I'm going to do is this. I'm going to go ahead and assume that I have 39 grams of each, right? And why am I picking that 39 grams as the number? Because that just makes this nicely just 1 mole here. And then this one, well, 39 times 2 is 78. And that's not quite 2 moles. So I don't know, let me just say like 1.8 moles for the sake of just estimate. This is a no calculator section, so the math they throw you here is really not going to be that difficult. So if you guys just want to use rough estimates like what I'm doing, it's always going to work perfectly fine as long as you're within the pretty reasonable margin. So let's think about it. Well, the stoichiometry it is that every time you run this reaction once, you're using 1 mole of potassium and you're only using a half mole of chlorine gas. So technically, if you have 1 mole of potassium, all you really need accordingly is going to be 0.5 moles of chlorine to completely react all that 1 mole of potassium, right? So given that, well, you have 1.8 moles, so clearly potassium is going to run out first. So that's our limiting reagent right there. So at the end of, I guess, the equilibrium, when you literally have no more potassium to run through, well, what are we going to have remaining in the solution or in the reaction vessel? Well, like I said, potassium is the limiting reagent, so we're not going to see any potassium left over. So anything that says potassium is out. So this guy is out, this guy is out. So B and D are out. And what do we only have? Well, we probably have the chlorine gas remaining. And what else? Probably your product that was just formed. So chlorine gas and potassium chloride, that should be answer choice C.